Hi everyone, and welcome back to Chem and Code. This is lecture 1 of Chemical Reaction Engineering, and as you can see, we have some applications of chemical reaction engineering. In the first video, I talked about what a chemical reaction engineering actually is. So, it is reaction engineering. We have two basic parts: the chemical kinetics and the design of a reactor. And in this particular slide, we can see that there are some applications where reactions occur and where we can apply chemical reaction engineering and find out at which rate we will have, what conversion we will have, and what um, different parameters that are required when we want some detail into how those reactions occur. So here you can see a very basic example where we have a hippo digestion. So the hippo is going to eat, and then its body acts like a digestion or a reactor, and it then digests, and finally we have the product. Then we have some other reactions, like here we have this reaction where in this reactor this reaction occurs and we have some volume in here and there is some conversion, so 80% conversion. So if we have some C2H6 here that enters, 80% of that is converted and then goes into the next reactor. Now what will tell us the volume that is required for this conversion, for 0.8 conversion or 80% conversion? That will be determined by chemical reaction engineering. And there are some other different applications for, like in, for example, in oil recovery and in cobra bites, multiple reactions in a batch reactor, body reactor, and then we have nitroaniline explosion. So there chemical reactions kind of happening all over the place, just, and therefore we can apply chemical reaction engineering to all different types of reactions that occur in our daily lives or even in the industry. That being said, let's jump into our first lecture, and this lecture is going to be about a chemical reaction, because first, if we're going to start chemical reaction engineering, we need some in-depth knowledge on what chemical reaction actually is. So before we start, I'm just going to give a recap of what I said in the first video. If you haven't watched it, we have two parts in chemical reaction engineering: the study of the rates and mechanisms of the chemical reactions and the design of the reactor. So two parts. First we will need to know how that reaction is gonna occur, its rate and mechanism of the chemical reaction, and the design of the reactor. So we need a reactor to perform that reaction as a chemical engineer. So the first concept that is very important before we jump into a chemical reaction is chemical identity. Now, a chemical species is said to have reacted if it has lost its chemical identity. The identity of a chemical species is determined by the kind, number, and configuration of the species of atoms. Now, if we have a certain species, for example, a sample of let's say hydrogen, we have a sample of hydrogen in a cylinder. Now how do we know, after certain processes or reaction, how do we know that this reaction has actually occurred, like chemical reaction has actually occurred? We will see what kind of react atoms are present. Are they hydrogen, and what is the number of the hydrogen that are in one molecule or in that chemical species and the configuration of those atoms. So three different things can be changed. Either the hydrogen atom changes itself, or the number of hydrogen atoms in that molecule change, or the configuration, how those hydrogen atoms are linked together or with other atoms may be changed. So in either of these cases, we will say that the chemical identity of that particular chemical species has changed, and therefore it has reacted and a reaction has occurred. So three examples of a chemical reaction from those three point of views is when decomposition of a CH3 molecule decomposes into hydrogen and ethene. So here we have dehydrogenation reaction. Here we see that some of the molecules, some of one molecule, let's say one molecule of ethane undergoes a reaction, means that its chemical identity has changed to an ethene, and we have liberation of hydrogen. And in the next one we have a combination reaction where two different molecules combine and form nitrogen oxide. And then there is the third part where we see that the arrangement of the atom has changed, but the number and the type of atom is the same. This is called isomerization.